Welcome to Bot Thoughts by AmtocSoft. I am Alex. The waste turned up in the least dramatic place. A nightly agent that summarized build failures. The job was useful, it read test logs, grouped the failures, and opened a report for the morning rotation. The problem was that most of the failures were boring. Missing fixture, timeout, package lock mismatch, lint rule, flaky browser test. We were routing every one of those cases to a frontier model as if each log needed deep reasoning. The bill did not spike in one visible incident. It crept upward in tiny calls that nobody wanted to review individually. When we sampled the traces, the embarrassing part was not just the cost. It was that the frontier model was spending premium output tokens on formatting, classification, and ordinary extraction. Tasks that a model 20 times cheaper could handle with a well-framed prompt. This episode is about how to build the system that routes the right work to the right model. Before we get to the solution, let me explain why agents hit this problem harder than chatbots. When a human uses a chatbot inefficiently, over-explaining their request, asking for unnecessary clarification, it wastes a single interaction. When an agent loop does the same thing, it multiplies across every step. A typical agent pipeline might have 10 or 15 steps for a task that repeats thousands of times per day. Classify the input. Inspect the relevant records, summarize what changed, choose a tool, parse the tool output, make a decision, apply the change, explain the change. File a report. Most of those steps are not frontier reasoning problems. Classification, summarization, extraction, formatting, these are bounded tasks with clear right answers. They do not require a model that can handle novel multi-step reasoning. They require a model that is fast, cheap, and accurate on a well-defined problem. The pricing math makes this concrete. On output tokens, which is where agent loops spend most of their budget, the differential between a small and a frontier model is typically 5 to 20 times. Claude Haiku versus Claude Opus is about 5 times on output tokens. GPT. Nano versus GPT-4.1 standard is about 20 times. In an agent loop where the same step runs 10,000 times per day, a 20 times cost differential is not a marginal saving. It is the difference between a system that is economically viable and one that is not. There is also a privacy dimension. If a local classifier can categorize a support transcript and route the boring cases without sending them to a remote API, you have reduced your data exposure before the expensive reasoning even begins. The conversations that never leave your infrastructure cannot be logged, retained, or involved in future training on someone else's terms. When teams recognize the cost problem, they usually make one of two mistakes. The first mistake is keeping everything on the frontier model because it is simpler. One API key, one latency profile, no routing logic to maintain. This is an understandable optimization for early-stage projects. The cost is that, as the system scales, the bill scales proportionally. You never build the measurement infrastructure to know which tasks are expensive and whether simpler models could handle them. And you leak more context by default, because every step of every agent run goes to a third-party API. The second mistake is forcing everything through a local model for a cost story. The team announces they have cut their API bill by 70%. What they do not announce is that the local model is handling tasks it should decline, that failures are silent or confusing, and that the team has quietly stopped trusting the agent's output on the harder tasks. The cost saving is real. The quality regression is also real, and it shows up in customer complaints and in the eventual manual review queue. A router is a third option. Give each model a job it can do, define the boundary explicitly, validate that the boundary is holding. Keep an honest escape hatch for the hardtail, the cases the small model cannot handle confidently. This is not a clever trick. It is basic software engineering applied to model selection. Do not use a more powerful or expensive resource than the task requires, and have a defined escalation path when the task exceeds the resource's capability. A production router has 4 components. Let me walk each one. First is the task taxonomy. This is the most important part, and it is the one nobody builds first because it feels like documentation rather than engineering. The taxonomy is a structured definition of every task category your agent runs. What it is, what a good output looks like, what a bad output looks like, which model handles it by default, and a small evaluation set of labeled examples. Without the taxonomy, routing is guesswork. You end up with a routing model that has learned a policy you did not consciously choose, and you have no way to know what that policy is until you audit the traces. With the taxonomy, routing decisions are testable. You can measure whether the router is assigning tasks to the correct category, and you can identify which categories have the highest error rates. Second is the local model path. The specific model matters less than the properties. Cheaper, faster, or more private for the categories you assign it. Whether that is Alama running a 5.4 mini quantized to 4-bit or a hosted small model from a vendor, the important thing is that the path is clearly differentiated from the frontier path on the dimensions that matter for your use case. Third is the confidence gate. This is where most router implementations are too simple. A confidence score alone is not sufficient. A robust confidence gate checks multiple signals. The confidence score from the local model, schema validity of the output, whether the output labels are in the expected set, output length relative to expected range, presence of refusal markers, and presence of high-impact keywords that indicate a case that should not be handled automatically. A router that trusts a single confidence threshold is a cost-cutting switch. A router with a multi-signal confidence gate is an engineering system. Fourth is the audit loop. Every routing decision should be logged. Task type, model used, latency, estimated token cost, validation result, escalation reason if escalated, and final outcome. This is how you detect drift. Routing policies that were right when you built them become wrong as your user population changes, as your taxonomy drifts, as model updates change behavior at the capability boundary. Without the audit loop, you will not know whether the router is saving money, hiding errors, or escalating too often. With it, you have the data to tune the policy. Once the router is running, calibration is an ongoing process, not a one-time setup. The single most useful calibration practice is this. Do not trust the router until you have manually sampled 200 escalation decisions and confirmed that the escalation reason is accurate. Escalations that say low confidence on a task that is obviously simple indicate the confidence threshold is set too conservatively. Escalations that say low confidence on cases that the local model handled incorrectly indicate the threshold is set correctly, and the local model just cannot do that task. These look the same in the aggregate escalation rate, but require completely different responses. 3 metrics to watch over time. Local handle rate, which should be rising as you tune the taxonomy and thresholds. Escalation rate by category, where a high rate on a specific category indicates either that the category is miscategorized or that the local model's capability boundary sits inside that category. And output quality delta, which requires sampling the same inputs through both local and frontier paths and comparing outputs. This last one is the hard one to automate, but the most important one to do periodically. The research foundation for this approach is Frugal GPT from Chen et al. At Stanford, published in 2023. The paper shows a cascade approach where the system learns which model combination to use per query type based on observed cost and quality. The production implementation I have described is operationally simpler. It does not require learning the cascade weights automatically, but it is grounded in the same principle: route by task complexity, validate the boundary, escalate when confidence is low. The goal is not to avoid frontier models. It is to earn the frontier model's attention. When every agent step routes to the strongest model, the strong model's context is full of intent classifications and log summaries. When you route the bounded work locally, the frontier model shows up for the decisions that actually need it. Small model first is not a cost story. It is an architecture story. Give each model a job it can do, measure the boundary honestly, and keep an escape hatch for the hard tail. Full router code at github.com/amtocbotdroid/amtocbotexamples/small model router. Blog 266 has the full pattern. long-form video V042, shorts S164 and S165. Subscribe to Bot Thoughts. I am Alex, and I will see you next episode.